All right, let's do it there. All right. So what do I do now? Which variable do you want to kill? Yeah, you could kill. Now the A is probably the one I would not kill. Because A would require me to multiply by -2 and -3, and then I open myself up to making more mistakes. These are already kind of, B is set up, C is set up. So let's kill the B. Just because I want to. So if you took 1 plus 2, you would get 4. Oh yes, you do. So we cool with that? This is the first equation plus the second equation. I'm going to make a fourth equation, right? That's all I need. So what is 1 plus 2? 3a. Careful. Equals. You're adding these together, right? 24. So a is 8. So we're in that situation, that same situation on that busted play yesterday, where I mixed two problems together. But now it's a little bit better. Those still both went out. I know A is 8. So this is a special case. I don't have two variables. I've actually got one variable solved. So what's the special thing I could do here? I could plug it in. So if I plug that into the first equation, I get 8. I'm going to subtract it. Is that cool? Can I do several things at once? I'm going to put an 8 there, subtract it, so I'm going to have 18. Is that cool? What's A? 8. So if I put an 8 there and subtract it, I get that. If I put an 8 there, I get 16. Subtract it, I get... Yeah, -18. So these two are actually the same equation. Do you guys see that? Is everybody cool with me doing that? Twice 8 is 16. Subtract this 16, you get there. I know A is 8, so I can plug it in. If I plug it in here, 3 times 8 is 24. Subtract the 24. So just plug an 8 in for A, and then bring that number over to the other side. So now you've got a bunch of B and C equations. Now which two would you not use? Which two?
B and C.
Yeah, 1 and 2, because those are actually the same equation. That's not going to get you anywhere. But thank God we got a third alternative. I can use these two. So if I add 1 and 3, I'll get
2C.
2C equals -6. Cool. I like it. So then C is -3. And then how do I get B? Plug C back in somewhere. Yeah. So the reason that didn't follow that same format from the other day is because the first thing I did led to a special case. I know A. Normally on this step I'm going to know A plus C equals whatever. I'm not going to know A, but here I did. Cool, so I can use it immediately. I use that information. Hell yeah. I'm a detective. Hey, the guy's going to be there. I'm going to go there. Shit, I'm here. What's going on? Right? So the minute I know A is 8, I use it. I get much better equations now, much easier equations to deal with. Why is that much easier? Because there's one less variable. Now I know C is -3. I know A is 8, but I can just plug -3 back in maybe here. So B equals, looks to be 21. I love some of your expressions. Like, yeah.
Can you go over how you got C again?
Is everybody cool with this step here? Yeah. I know here A is 8. So I plugged 8 in. I got these 3. Now if I look at this one and this one, I can add those together and B goes away. I get 2C equals -6 when I add those together. So then I know what C is. Yeah.
So there's only 2 answers? Oh, never mind. I didn't see the bottom one.
Yeah, there's got to be 3 here, right?
3 here.
Cool. Yeah.
Different ones, Mom. 11.1.
Oh, just a second.
One second. Here you called B and C or just B? When I equal, yes. You called B and C?
Yeah, it just happened. I was really focused on B, but C also died, right? So that's just a lucky break. So I get 3A equals, those both went away, and I get equals 24. So I just happened to luck into knowing what A was. So the minute I know what one of those letters is, I'm going to replace it with it. So I got less variables to live with. And then I got 3 equations. I can use any 2 of those to kill stuff and keep going, yeah. Yep.
Now that you know A and C, couldn't you just plug it into the first
Hell yeah, and it's got to work. So if I plug in 8 plus B minus 3 equals 21. Oh, 26. I'm thinking ahead. Then you solve, you get 5, subtract 5, you get 21 there. So you still get B equals 21. All of these equations, the whole point is you find the place where all 3 of these have the same answer. Let me say that again. Isn't that the point? Right? You find the spot where all 3 planes have the same answer. And what does that mean to have the same answer? They all exist at that point. Right? 2 lines going through points. The one point they both exist at is the one point that works in both. So planes the same way. The one point that lies on all 3 planes is the one that works in all of them. So it doesn't matter which one I use, either one of these or any of the equations that come from combining those, they're all going to have the same answer because they all indicate that point. Hopefully. So it doesn't matter which one you use. Yeah?
How do you get C to equal -3?
So I got here, and then I added these 2 together to see how the B's would go away.
Yeah.
So I get 2C equals -6.
Or 2C.
Yeah, C plus C, yeah. Yeah, be careful. Okay. All right. What was the question here?
11.1. Number 15.
What number is this?
Number 15,
Yeah.
On what section?
page 689, 11.1. So, is there something specific that happens here that's freaky?
Yeah.
Oh, Jeff, please don't do that again. So, whenever I'm tutoring somebody or helping somebody out, the very first thing I do when they sit down and say, I have trouble with this problem, is say, can you show me in the book and compare? Because very often, that's all that happened is one thing got written down wrong. Or like me the other day, combining 2 things. So it's the first thing you check after you write something down is make sure it's the right damn problem. So what did you do first here?
I took equation number 1 and 2 together.
1 and
2 together.
1 and 2, you added those together?
Yeah. I get y equal -3. Then when I took...
Wait. So you actually did
1 and 3.
1 and 2.
well, 1 and 2 would be 3x plus 4y plus 3z.
Yeah, I multiply number 1
Oh, okay,
with
there you go.
-2.
Now we're talking. So you multiply number 1 by
-2.
-2, is that cool?
Yeah.
So she's thinking about killing that x? Maybe, so she wanted to multiply this by -2?
Yeah.
So we see something going to happen here. Is everybody with me here? Is that cool? And then you leave number 2 alone?
Yeah.
So what happens is that goes away, but so does that.
Yeah.
It's a lot like that last problem, right? So in here you get y
-3.
is -3.
Then when I take number 3 with number 1, I got also y equal -1.
I love it.
So now it's 2 letters, y.
Contradiction, right?
Yeah, so
There you go.
what can I do?
No, you didn't do anything wrong. What does it mean? If it contradicts itself, what does that mean? No
No
solution?
solution?
Yeah,
That's it?
that's it.
Thank you.
You want?
So if I have 0 equals 0, also
That would be,
all near, all the
yeah, that
number?
would not be all real numbers. That would be, in this case, that would be a little interesting. That would mean it's a line that they meet at. So it would be all the points on the line where they meet. It would be an infinite number of solutions.
Thank you.
But this one, she said, when you add these two, you get y equals negative 1.
Yeah.
It's easy.
And so that's a contradiction right there. So that would mean no solution. So that would be like this plane and the floor and the ceiling. So that plane hits that plane there, but that plane hits this plane there. So that's what it's really telling me. Y is negative 1 and y is 3, negative 3. It can't be both. Right? So 3 planes don't all have to meet at one point. They can do a lot of weird shit. 2 of them can be parallel, and the third one's coming in hitting them. Right? 2 of them can meet, and the other one. So you can have, if you look edge on, you can have planes that do that. If I had, yeah, planes that. Imagine another one coming. Right, planes that kind of hit each other, and then there's another one at the bottom, like a triangle. Right. So will there ever be one answer for that? No. You'll get like an answer. That would be like the y equals negative 1, and this would be maybe the y equals negative 3. That's telling you, oh shit, they don't all meet at one place. So there's no answer to that. There's no solution. Right, so there's a lot more ways for planes to not line up right, to have no solution. Okay. So let me do this. There's a part of the practice test on the answer key that I left undone. Just because I got to the end of the back page and they said, screw it, I don't have no room, I don't want to, we'll do it in class. We'll do it live. Nope, is that reference really already on? So here's the answer key for the practice test. What's that? Oh, no, this is for you. This is completely yours. You can make it into a paper airplane or whatever you want to do. So, I got through 11D. So I definitely want to do 11E through 14 here in class. Let me go ahead and do that now. And then we'll take a step back and see if there's anything else you want to talk about.
Yeah.
Everybody see what I'm talking about? So the answer key, I stop at 11D. And then I say, rest in class. Not meaning take a nap, but meaning that I just didn't want to do a whole nother sheet. So 11E. So this is the rest of the answer key. And then we'll do some whatever specific ones you want to look at. What is it about 11E that tells me what I should do here? Good. Why is it grouping? Because there's 4 terms. So if there's 4 or more terms, you try grouping. I don't put parentheses because if you put parentheses here, you got to remember to change that sign because you effectively just took a negative out. I don't want to deal with that shit. So I don't put parentheses in there. If you like it and you do it, great, do it. But everybody pretty much almost always makes the negative mistake somewhere in here. But here, what do I take out?
X squared.
X squared.
X plus 2.
X plus 2. I know this has got to be the same as this, so I need to take out a negative 9. So both these signs will change.
That's my mistake.
Careful.
Sorry.
Now, if you did get this, real quick, I always get somebody get this, and then they tell me the answer is that.
Yeah.
Which there's just nothing that goes from here to here. Math will go, I ain't got nothing to do with that. Right? There's nothing. No, that's no good. I can't do the next step unless these are the same. So if you do this, you just check it. Negative 9 times negative 2 is not, oh shit, that's going to be a plus. Right? And now I'm allowed to do the next step, which really is itself a GCF step. What do both of these terms have?
X plus 2.
And that's what tells me I can do the next step. You take that out, you're left with. Now, if you stop there, you've made the same mistake as if I asked you to factor 18 all the way, and you tell me it's 9 times 2 and you stop. What mistake did I make? I didn't do all the way. 9 is 3 times 3. So here, I didn't go all the way. Because this piece, I go further. Yeah.
How did you take the x out, though? Like, how did you drop the x squared and get rid of the 9?
Watch this. Factor that for me. What comes out? That's an A, but let me make that a Y. My A's kind of look like 9s.
Y outside.
Yeah, what comes out?
X squared and then y minus whatever.
Y comes out.
Yeah, just the Y comes out, right? What's the GCF of both of these? Y. And what's left? Take a Y out, you get X squared. Take a Y out, you get 9. So that's GCF. Now, what if Y was X plus 2? That's exactly what I have here. X squared Y minus 9Y. The Y comes out. And I'm left with the other stuff in each. Right? Because what's Y? A number I don't know yet. What's X plus 2? A number I don't know yet. So they have to act the same way. They're basically the same type of thing. Right?
So where does the x squared come from, though? In the
It's there.
Okay.
So if I take an X plus 2 out of both of these, if I take an X plus 2 out, what am I left with? X squared. And if you check it, if you multiply X plus 2 times X squared, there it is. Multiply X plus 2 times negative 9, there it is. Right? So I'm just undistributing X plus 2 back out. Is that cool? Now how do I go that next step?
X plus 2.
Yeah, this stays the same.
Square.
Difference of squares.
Good.
X minus 3. X plus 3.
I like it. And that's your real thank God problem. Cut it in half, plus minus. Okay. Yeah.
So if it were to be x squared plus 9, then that's the answer, right?
Yeah, then you couldn't go any further because you can't do a sum squared to 11. But since this piece is doable, you go further. It's the same thing as if I asked you to factor 6. All right, neither one of those goes further, so you wouldn't go any further, right? But this one does go further, so you got to go. So that's 11E from the practice test. And then 12, we get the function. So I like giving you these visuals here and asking you stuff. So 12 references the blue graph. I always have somebody come up to me during the test and they say, how can I do this? You didn't give me a function, Joe. I got nothing to plug into. But when you have a function and you plug something in and you get something out, what did you actually just find? So if I have a function and you plug something in and you get something out, what is this physically?
Input output.
It's a point. I love it. So then you would go plot it, wouldn't you? You would go, here's 2, bam. But if I take all that crap away and I say, what must f of 3 have been? And well, it must have been 2, because that's where somebody put their point, right? So I don't need a function here. Somebody else had the function. They did all the work. I'm just going to come in and go, hey, work. Let me see. So f of 4, what must f of 4 be? What point does was 4 go to? This town, actually. I try to make it look more like -5 there. Is that cool? negative 2, negative 4, and it's right here, so it's actually negative 5.
So you just plugged it in right there, where you put -5 on the
Yeah, so the answer here would be negative 5. And why is it negative 5? Because an input of 4 has an output of negative 5. How do I know that? There's a point there. Yeah.
That's because the x-intercept is at 4, so f of x, so the 4 would be 4.
Well, be careful now. The x-intercept's not 4.
No,
But
0,
if
4,
x is 4, what must y have been? Well, it must have been negative 5 because that's where the point is.
That's
Yeah,
what I'm saying.
cool. The x piece is
Yeah,
4.
the x piece is
And the y piece would
has
be
to be on
negative
there.
5.
Yeah.
So really, this question is asking you, what's the y piece if x is 2?
So always the function is x. Always the function is x.
Yeah, this inside is
X.
x. Yeah.
It's x. Okay.
Or whatever the input variable is. It could be t for time or something, but in general it's x.
Okay.
So what's f of 2 going to be? Negative 2. Why? Because at 2 has a point at negative 2. Is that cool?
Yeah.
It's even better than having the function because somebody already did the work. I just got to see where they put the point. And I got the answer. That's better than give me the whole freaking function. Domain and range. So what domain would be what variable? Like the answer, but what variable? X. So what's the smallest x? That has an output, negative 4. What's the biggest x? 6. 6 is the last output, right? The last one that has an output. Where do all the outputs go between? What's the lowest output? Negative 5. That one we found earlier. Up to 4. Cool, so that's the y's, that's the x's. How far do the x's range? Let me say this again. How far do the x's go? How far do the y's go? Right. Can't use that word range now. In the
Why
wrong
you
place.
use just -5 for?
Say again.
Why you just put -5 and 4?
Because what does the, you do this really. The lowest output is negative 5. And the highest output was 4. So how far do the y's go? From negative 5 up to 4. This goes through no points to have a y lower than negative 5 or a y higher than 4. Right? All the points on this graph have a y piece in between negative 5 and 4. That's what the range really means. It captures all the possible outputs. There's no output bigger than 4, no output smaller than negative 5. I can't think of another way to say that. So, okay. Any questions on number 12?
If it would have been like an arrow instead of a point, it would have been infinite, right?
Yeah, I would have had to assume it would continue in that fashion. So, the range, if I would have put an arrow here and here, the range would have still been negative 5 to infinity. Because now that would imply that it just keeps going up forever. Right? But I didn't do that. I stopped.
Right.
Cool. Anything else about number 12? Okay. What about 13? What do I have to use to solve those things?
Equal
Put
0.
together.
Yeah, good. Equals 0 and then
Yes. And group.
factor. Good. So 13a. So you bring this stuff over. And then you factor. Actually, I think a grouping would work too, but I don't think I meant to do that. It just happened to be. How do you factor this? Is everybody cool with that?
11.
If that wasn't there, would I do all that shit? No, I can get x by itself. Why can I get x by itself? Because they're all like terms. All my x's are like terms. I can get them all together in one place. That stupidity right there messes that up. There's no way to get x by itself directly. So I need this indirect route. I need to factor this thing.
Negative 11, negative.
Yeah. So negative 11
Negative
Three.
3.
and 3. Good. So what does this lead to? X equals
11.
11, because that's what makes it 0. Or x equals 3. That's what makes it 0. I love it. So it's a compromise. One ugly squared equation becomes two not so ugly first power equation. I can do that. The mistake I always get is somebody gets somewhere like here, and they say, okay, x minus 11 equals 4, or x minus 3 equals 4. No. Why is that not? Why can't you do this, but you can do that? What do you multiply to get 4? 4 and 1, 2 and 2, 8 and 1/2, 100 and 1/25. So how many possible answers are there from what I know in this equation? Infinite, no. Shit. But if it equals 0, then one of them has got to be freaking 0. It's either this dude or that dude. Bam, I'm done. So it's got to be equal to 0 for this thing to make any sense. So if it's not equal to 0, you actually have to multiply this out, subtract the 4 over, refactor it. It's got to be equal to 0. Yeah.
So just to recap, you have to set it to 0 when you put the x squared because when you bring everything over. The
Exactly. If there's a higher power on the x, you get everything on one side, make it 0, and then factor what you end up with on that side. Yeah.
So then your answer is just x equals 11, x equals
Yep.
negative 3, or what's that? I can't read that.
X equals 3, right? Because what would make this 0? 3.
3.
And 11 would make that 0. Because the step I'm skipping is x minus 11 equals 0 or x minus 3 equals 0. If one of those is 0, the whole thing is 0. And you just solve each equation. Right. Okay. Anything else about 13a? Yeah.
No,
I get how it works. I just don't know why you would, like, how do you know you're supposed to factor in not just x by itself? Like, I get how you got the
Can I get x by itself? In order to get x by itself, I have to be able to put all my x stuff together in one term. Can I put these together?
No.
That's what tells you.
Okay.
Yeah. So that's what I meant by if there's a higher power on the x. Most often that'll be this kind of problem. Right? Yeah.
So then you have to go back in and plug 11 in and do it, and then plug 3 in. And
To
do
check it, you're done with the problem. If you want to check it, you can check it. All right. Is there anything else about 11a? What about 11? Oh, sorry. Not 11. 13. Where am I at? 13b. The same idea, but the biggest mistake I get here is somebody divides by x. What could x be? What could x be that would make dividing by it bad? Yes. So you can't divide by a variable unless you've already stated that x can't be 0 or something. So no, don't do that, because 2 reasons. It could be 0, so it would die, and you lose an answer if you do that. Specifically, you lose the answer that x itself could be 0. So I have to pull that over. What tells me I've got to get it equal to 0? I've got a higher power on one of my x's. And then you just do what with this?
X minus 1.
No.
Not quite there yet.
Outside.
Factor it. Take an x out. And then so x equals
0.
0,
Minus 4.
negative 4,
4.
4. All right, 0 would make it 0, and negative 4 would make it 0, a 4 would make it 0. So those 3 answers. Notice something. What was the power here?
2.
How many answers did we get? What was the power here?
3.
How many answers did we get? Interesting. Will it always be that way? No. You gotta be careful. Sometimes you'll get answers that repeat. Real quick, if I had, go with me for a second. Right, it's a squared power. What I just said is I expect 2 answers. I do get 2 answers. How do you factor this thing?
X.
Yeah, x minus 3, x minus 3. So what's the 2 answers? 3 and 3. I'm not going to put them down twice, but there are 2 3s. So there's always going to be this many answers. Now, the next level of difficulty is some of those answers might not be real. Some of them might be complex. We're not there yet. That's why we need complex numbers, to keep that kind of true. If it's a fifth power, I expect 5 answers. Maybe 4 real ones, no, 4 complex ones and a real one, possibly, right? But I expect 5 answers. Maybe I'll get 5 2s, right? But it's still 5 answers if it's a fifth power. Okay, so that's getting a little ahead of ourselves, but that's all right. Yes?
Number 13b. You can divide over x.
You could, if you first say
Just 1 point.
x equals 0 is an answer, so now I can divide by x.
Yes.
Yeah. But you got to first take into account that. You can't lose that answer.
Yeah.
Good. All right, so what about one last one here? Number 14. Yeah. 14. Now, I think, I think this is getting a little ahead of myself, but that's too bad. This would not be one where you would long divide, thank God. This is actually, I probably won't put this problem on the test because you might think that way because we haven't officially gotten here yet. But when I see this, what kind of thing is this? What kind of number is this? I love that question, like, what? If I made x 7, this would be some number over some number. So this is a fraction. How do I simplify a fraction? Reduce it. Right? So how do you factor the top? How do you factor the bottom? And you see what's common. It's exactly how you would do 7 over 14. Well, that's 7 over 7 times 2. The 7s would cancel. That's 1. So here, I can't do it as easily in my head because it's not just numbers. It's freaking variables. So I take a second and I factor the top. How do you factor the top?
Of the x.
Good. Take an x out.
X squared.
X squared. 5.
And what on the bottom?
The same.
3.
Yeah, take a 3x out.
X minus 4.
I'm not done on the top yet, right?
Yeah. X.
So what numbers work? 36 and 5 here?
Plus 9 minus 4.
Yeah, I want it to be 9 and 4. And the 9's got to be positive to make this come out to be plus 5. And now what cancels?
X and x minus 4.
And?
X.
So what's left?
X plus 9.
X plus 9
3.
over 3. I love it. So who survives, right? So this, when we get into this problem, we'll be doing a lot of killing. They kill each other, and who survives? And where are they? Right? Yeah.
So there's no way around long division, like when we get those, we can't do
Yeah, I'm going to specifically say use long division.
Okay.
Yeah, there's no way officially around it, especially when I say use long division. Plus, you're not. If I say use long division, you could have remainders. Remainders mean that this won't go in evenly. There's no way to factor it to make it work. What's that?
We can divide like a long division because we don't have any number multiplied by 3 to get x.
Sure you do. 1/3. So I could make you do long division on this if I really felt like being that way. But I'm not going to. Come on. Yeah.
I'm with you all the way down to where does the 9 come from? I understand factoring being the lowest common.
So right here?
Yeah, so
Right there?
yeah.
How do you factor this guy? You need 2 numbers that do what?
Add the 5.
Yeah, add the 5.
Multiply the 36.
And that would be 9 and 4. Right?
Okay, so you factor
Positive 9 to make that plus, negative 4 to make it become negative when I multiply. Right?
Okay, so you factor it again. So now I get where you got that top from, and then it's at that point you
Start canceling because I'm done factoring. Now I kill all the common stuff.
Okay, so then where does that? Oh, that's why it's over 3. Never mind.
Because that 3 is left
Yeah.
alive. Cool. Now, of course, you can't do this. You cannot do 9 divided by 3 is 3 there. Because what's being divided by 3? X and 9. Yeah, so you can't just make the X escape. Yay, no.
And even x plus 1 over 3 would be wrong. Or if you reduced, you know, like that. You can't do
Yeah,
that.
it would be wrong because if you put a 3 there, now 3 divided by 3 is 1, and 1 divided by 3 is 1/3. When would it stop? I mean, so you could, the most you could do is x over 3 plus 9 over 3, which is 3. You could do that. But why would you? Yeah. I mean, you could. Okay, so that completes the answer key, right? Because I left those problems off at the end. So now it's wide open. Yeah, to whatever you want to talk about.
Section 9.6, numbers 48 and numbers 47 and 49.
Oh,
In the white book there.
thank you. 9.6, 47, 49? Oh, yeah. Okay, so we got this here? Yeah.
I have a quick question on that answer key.
Oh, okay. Just a second, let me...
I'm not sure if I'm getting it wrong or if you got it wrong on number.
I could very easily do that wrong. Let's see.
Because how is the stay up?
P4. Yeah, it should be up. Good. So on, what was that? 1? Yeah, 1F. That was the other reason I stopped, is because it became late at night last night. I'm like, okay, I gotta stop. So this should be this. Those P should be on top. I don't know how they snuck downstairs. There's P5 over P, 1P would cancel. There's P4 still on the top, right? So 1F should be this. The P4 should be on top. Yeah, I'm averaging about a 97 on my answer keys. So 9.6 in the white book. These two are word problems. So number 47 says the base of a triangular fountain is 2 feet longer than its height. So I pretty much give you the picture there. The area of it is 24 square feet. What are the dimensions? So the biggest mistake people make is they forget that it's a triangle. What is the area formula for a triangle?
1/2
Yeah, 1/2 based on its height. So here the area would be 1/2
Times B.
What's the base?
X plus 2.
H plus 2. What's the height?
X.
H.
H.
And what is the area supposed to be? 24. So now you solved that. This is a really good example. If we double both sides to kill the 1/2, not a bad idea. And then you get here. This is where I have people tell me, well, H plus 2 equals 48, or H equals 48. I exactly cannot do that. This property only works if it equals 0. So I have to multiply this out and suck the 48 over, right? It's almost like somebody factored this too early. Oh shit, they're going to multiply back out and bring the 48 over. Right? So if you multiply this back out, bring the 48 over, now you can refactor it and go from there. You cannot get answers to this kind of thing unless it equals 0. You could, but it would be really difficult.
But I thought the base was 24 though. What? How do you end up with 100? You just timed it by 2.
Area of the base is 24, so the area is 24. And then I multiply by 2 first just to get the 1/2 out of there. I don't like the 1/2. Is that cool? I have an equation with a fraction in it. I really don't feel like distributing that and dealing with it. I'm just going to double it and kill it. No, you don't like it.
I don't understand where you get the half from.
What's the area of a triangle? 1/2 based on side. Right? This is not a rectangle, so I need that 1/2 in there. Yeah.
And this question, I have two solutions. X, H plus equals 6 and H equal minus 8. But when I put it in the,
Well, right off the bat, right there,
yeah, I have
You
also
eliminate-
four solution. Yeah.
Careful. This is an actual existing fountain, right? So the height obviously cannot be
Minus.
negative. So throw that out right there. Yeah. So you will get two answers here. One of them will be negative since this is a physical situation involving things that can't be negative. I throw the negative out. So it's not math making a mistake. Math is like, this could mean profit, and you could have negative profit. This could be time, and you can actually have negative time. Before this happened, that's negative 8 seconds ago. But we know it's freaking length. I got to throw the negative out. I'm like, thanks, math. I don't need that.
Can you please explain what happened with the 1/2 again?
Anytime I have a fraction in an equation, a really good first step is to get rid of it. And I'm allowed to if it's an equation because to kill 1/2, I would multiply by 2. And the reason I'm allowed to do it is because I have another side that will balance me out. If that was sitting there by itself and I said do that, you can't double it because there's no other side to balance it out. You have to just deal with the 1/2 thing. Thank God I don't. 49 was the other question?
Yes.
What's the formula that relates those three sides? Yeah. And real quick, if I draw a little square off of each one of these, the area of this plus the area of that equals the area of that. That's really what that says. A squared plus B squared equals C squared. So now you just plug in there what the side lengths are. C has got to be the longest side, the hypotenuse. That's the only one that matters. The other two, I don't care. Just plug the other stuff in there. And on that problem, they give you all the sides. So just plug the 2x minus 1, the x, and the 17. You actually get nice answers. Very often, Pythagorean theorem won't lead to nice answers, but there are some triangles like the 3, 4, 5 triangle, 5, 12, 13, and there's this one. Yeah.
Thanks for actually doing that out because I sort of got to a place where I couldn't.
Yeah.
Say again? I'm sorry, which one?
Just 49, just doing it and stuff.
Oh, this guy.
Yeah.
So they tell you, so for this triangle, they tell you it's 2x plus 1, plus 1 or minus 1?
Minus 1.
So then I have x squared plus 2x minus 1 squared equals 17 squared, right? The square of the two legs equals the hypotenuse squared when you add them. Now I just got to FOIL this bad boy out. The biggest mistake I would see here is somebody would tell me this. What has that person done wrong? I like that. Can't do that. Be a little more specific. What do you have to do here? They distributed, and of course exponents don't play well with subtraction that way. You have to write it twice and FOIL it out. And 17 squared, I don't remember.
289.
189, I think.
289.
289. And now I just FOIL that out, get your like terms together. It comes out to be, one of those problems where you have to have the first numbers not a 1. So you have to do what I call the surefire method. Or the master product, or whatever the hell, AC. Whatever your name you use, it doesn't matter. Right? Oh, that's the part you guys want to see?
Yeah.
Right. So cutting to the chase here, I got x squared plus 4x, or 5x squared, minus 2 minus 2 minus 4x plus 1. Suck the 289 over. I get 5x squared minus 4x minus 288. That looks beautiful.
No.
Right? So I need 5 times 288, which is something. 1,440?
Yeah.
Is that right? Okay. So negative. I need factors of that make 4. All right, let me just stop right there for a second. I got a lot of people looking at me like, what is happening? So they give me the sides of this triangle. I know Pythagorean theorem is true for right triangles. plug in the side lengths, and I end up with this equation. That's what I got to solve to figure out these x variables, right? This is the equation I have to solve. So you do that. The first number is not a 1. So you multiply those together. I need factors of this that make -4. This is the perfect one where I would do this. Give me two numbers that add to be -4. They're going to be different signs, right? Somebody start us off. 20 and 16. If the 20 was negative, that would add to be -4, right? Does that multiply to be 1440? No, what does it multiply to be? -320, right? You guys kind of with me? Way too small. So let me take a big step up. -30 and 26. Those would have had to be -4, wouldn't they? What do you get when you multiply those? What's up? We get -780? You guys kind of with me? You see how it's almost like Price is Right? Remember that show, Price is Right? You used to have Bob Barker and all that stuff. Now it's got different. So you see how I'm getting closer to what I want? So I just take another step. -40 and 36. They would make -4 if I add those together. What do I get when I multiply those? -1440. So those are the ones that I use. That's a lot easier than trying to factor 1440 until you go blue in the face. Because how many ways is there to factor 1440? Too many. It's a lot easier to just make two numbers that add to be -4 and then check to see if they make this too. They just have to do both. Who cares which one they do first? That's why I don't understand why more of my colleagues don't teach it this way. I mean, who cares if you get the factors or if you get them to add right first? Just make them do both in the end, and there you go. These do both. So what do I do with these? Yeah, I break up that middle term, right? Wait for somebody to say, I'll tell you what to do with those. Plus 36x. So I have not actually really changed my equation at all. I just rewrote it in a better form, because now what can I do? Group it. So I'll let you at least finish that out yourself. Remember, this is a physical object, so you can't have negative values if that ends up with negative values. And it will.
I don't understand this stuff. 5x2, no, 5x2 minus 4x. 5 from where?
Oh, I multiplied, I FOILed this out. I just did it real quick. If you FOIL this out, you get 4x squared.
Okay.
Plus x squared. 5x squared.
And 4x.
Minus 2x, minus 2x, minus 4x. Plus 1. I mean, I just FOILed it out and got it, just to cut to the chase.
Yes.
Yeah. That I have faith that you guys could do. But I skipped some steps there.
Yeah,
Yeah.
for that I...
Yeah, here's.
48. The same section.
Oh, what you need to get started on number 48 is, if I have 2 pages in a book, what's got to be true about those page numbers?
1,
If this was 17, this will be
17.
18,
18.
right? So if this is x, because I don't know what it is, this one's got to be
X
x plus 1. Okay. And so they tell you if you multiply 2 page numbers, because of course you have to do that all the time. But if you did multiply 2 page numbers, they make 156. So now if you multiply that by that, it makes 156.
Multiply.
You solve that equation.
So we multiply x.
Yeah, so when you multiply 2 page numbers, you get 156. Now you can distribute, bring that over, factor. It feels a lot like this one, just with better numbers. Yeah, and then I'll go there.
In the McKeith book, page 343.
A McKee question, all right. Number 27, I like it. All right. You didn't have a question about this one up here, did you? Dude? Forgot your name. Did you have a question about this one?
No.
A different one? Okay, hold on. I'll get to you next. So in the McKeague book, if you have the blue book, it's page 343. It's the one about the adults and the kids going to a show. Tickets cost $2. $2 for adults and $28 for kids. I mean, $1.50 for children, because they just don't make much money. How many adult tickets? How many children? If a total of 127 tickets, and the money made was $214. Now, do you see how there's two ideas and there's two unknowns? So I can make two equations. Right? So this first one, there's almost always a total equation, which is the easy-ass equation, which is the x plus y equals something. In this case, I might want to use
XY.
No. For adults, X.
AC.
Adults, X.
I'll use A and C. So we got A plus C equals 127. So there are 127 total people there, counting adults and children. If the adults were smart, they want to outnumber the kids. I don't have kids, so I don't speak from experience about it. And then for the money equation, I have to have money plus money equals 214.
2A.
Yeah, so if there were A adults and it's $2 per adult,
For adults.
I made 2 times A money from the adults, right? Bless you. If there were 30 adults, I would have made $60. So there are A adults, I make 2 A bucks.
Plus.
How much did I make off the kids?
Half C.
Yeah, 150 C
Yeah. That's one.
equal
200.
all the money you got.
Yes.
I like it. Well. And now you can do elimination, substitution, whatever you want to do. Right?
Also supposed to fraction.
Where are we at?
So you eliminate 12.
Yeah, you can do elimination method, maybe multiply this by -2. You can subtract C and plug it in there. You can do the substitution method. Whichever way you like better.
Can you do 29?
Is that cool? Can you guys finish that one out?
Yeah.
Does that get you there? Let me go to here real quick because I skipped you over. What's your...
It's just it's the percentage one on page 579, number 74. Just the setup again.
So in the white book, 579, number... Oh, yeah, okay. All right.
I understand you can't just take the percentage of the number. They give
So
you.
watch this. This one happens to be marked up, right? So let's say I had what do I have, Jeff? I have a shirt at my store that costs $20. I'm going to mark it up by 10%, right? Maybe it's a Spurs shirt. And there's going to be a lot more people wanting to buy it because they're about to kick the E's ass. What are my Heat fans? Any? Aw, that's an optimistic though. Alright. I'm just so hopeful. You can't even understand. So how would I figure out how much the shirt's going to cost now after this? What would I do?
18.
Just times
18.
What is that?
Mark up. I'm going to mark it up. Be careful.
Oh.
You're just gonna get 10%. So like
Good.
0.1 of 20 is.
Good. 10% of 20 is 2. And then I'm going to do what with that? Add it to 20. Right?
Yeah.
So in the real world, we know what something is currently, and then we can predict what it's going to be. And so this would be 18. Or not 18, 22. And yeah, you're going to do it. And the problem you're looking at, I know the price at the end, after the 5% markup, was $42. Do you know what the original price was?
No. You just
No, so instead of 20 here, I got to put I don't know, plus 5% of I don't know. But you see how the format's the same. How do you mark something up? You take that percent of what it is, added to what it is. But I don't know what it was to begin with. So 5% of something added to that thing gives me where I am now. It's the same exact setup. What if this would have been a discount?
I was actually accidentally reading the one above it, which was throwing me off 73,
Oh yeah.
which isn't even on.
Yeah, well then you got tomatoes involved, and that's freaking you out.
Yeah, it's the same thing.
But real quick, if this would have been a discount, the only thing that would have changed,
Minus.
there would have been a minus there, right? So everybody tries to do 5% of 42, but this equation, if you see where this came from, you see why that makes no sense. Those never do anything together. So why would 5% of this lead you back to the answer? It can't. So almost all percentage problems in algebra will have this kind of format. I ate something and I wanted to get 15% tip, and I gave them $80. How much did the meal cost? Bam! Right? My meal plus the 15% tip on that meal was $80.
So, but where do you go from the x plus 0.05?
Oh, so what's a whole x plus 0.05x? 1.05x. Right? Isn't this 1x?
Okay.
Which is 1.00x if you want to?
Yeah.
So it's like $1 plus 5 cents. How's that? If it would have been minus, it would have been 0.95, right?
And then you just divide that.
Then you just divide that.
by
I love it.
42.
Into 42, yeah.
Okay.
Excuse me. I
Yes.
don't understand what does mean markup.
Oh, markup would be just an increase. The big word there is up. If you mark a price down, I'm actually marking on the tag a lower price. If I mark it up, I'm putting a higher price on there. I've gone up by some amount. Yeah.
For that, does it work 18? Minus $2 from.
Yeah, because it would be a mark down then.
That's up.
If I mark the price down, I'm making a decrease. Here, I'm making an increase, marking it up. Good. Yeah.
Can you do page 343, number 28?
And before I forget, if there's ever, especially on a test or a quiz, if there's some word or some phrase I use that doesn't make sense, even because it has nothing to do necessarily with what language you originally speak, it has to do with the way that I mangle English sometimes. So just come up and say, what did you mean here? Can you say this a different way? I don't want that to be the problem. I don't want that to be the reason why I do bad on the math test, is because I can't put together a good phrase, right? So just come up and say, what the hell did you mean here? Sorry, which one?
In the McKeek book, 343, number 28.
And 29?
All right, so let's see. So everybody got this here? I'll take that as this. So 28 in the McKeek book. John's got 20 coins. Totaling $3.20. Living high tonight. If he only has dimes and quarters. So incredibly enough, I'm going to call that D and that Q. You get dimes and quarters. How much of each does he have?
D plus.
Yeah, so remember what I said earlier. You almost always have a total equation, which is just your variable plus your other variable equals some number.
20.
So the dimes plus the quarters makes 20 coins total. Now in this case we have another cost equation, or in this case a money equation. I know my total money is $3.20. How much does each dime give me?
10.
Now be careful. If I write this, considering what I've already written,
Like,
Yes.
0.1. Or make this 320 cents. Well, it's not a bad idea because then you don't have decimals around. 10 cents per dime plus
25.
25 cents per quarter gives you 320 cents total, which is what $3.20 is. Right? But you got to do either that or this. And of course, those are the same, aren't they? Because I can multiply by 100 and kill the decimal anyway. Make up your mind, Jeff. All right, let's do that. And now you just elimination, substitution, whatever you like. On that was number, what was that? 28. 29 is an investment problem. And this is the one he says, Miss Jones. That's her real name. Invest money in 2 accounts. Into a 12% account. And where'd it go? 15% account. I love these problems because I'm like, Miss Jones, what the hell's your problem? Just put it all in the freaking 15%. But obviously, maybe there's some risk involved and all that kind of crap. You with me? So there's got to be some reason this makes sense. If her total investment is $12,000, and she makes, where'd it go? $1,650 in a year. How much did she put in each? Because she's completely absent-minded. She forgot. She just had $12,000 laying around in her pocket. Oh yeah, $12,000. That's right.
You mean he has two accounts or one?
Yeah. Huh? Say again?
Okay.
She has 2 accounts.
Okay.
So this is where my variables come into play. And there's really, I'm not going to call them both A or something, so I'll call this one X and this one Y. Why not? So that's the amount that she put in this account, there's the amount that she put in that account. So it's the first easy equation.
Yes, X plus Y.
Yeah, she had 12,000 total. Now the hard equation is, how do you get that interest? I know the next equation is going to have something to do with that $1,650.
Yes.
How much interest did she make off of the 12%?
12%.
12% of X. How do you write that mathematically?
Yes.
Yeah, 0.12X. So 12% of the money she put in the 12% account is interest, plus 15% of the money she put in that account. And when she adds those together at the end of the year, she made $1,650. Not a bad year. Something is how much I have in my account. But now you can, again, now I'm going to stop there because that's the hard part normally is setting it up. Now that this should be the easy part is elimination, substitution, whatever you want to do.
Will we make X plus Y 12,000 from where?
It told me it had $12,000.
To account together?
So she had a total of 12,000. She put some here and some there. So when you add them back together, it's going to be the 12,000 again.
And the second number?
They gave you that again. That's the 1,650 interest.
Okay.
So it's the 12% of the money there and the 50% of the money there. That makes the total interest she made. Yeah. Okay. Now, if you don't have any money in a bank, you know the reverse of this, which is like paying back loans. Maybe some of us had car loans, or maybe even some student loans, or they are in your future. Right? It wasn't that long ago that I paid off my student loans. I had like $30,000 in student loans. Yeah. So, yay. All right. So anything, where are we going next? Any other questions? What do we got here? We're doing pretty good on time. Yeah.
In the white book, section 11, number 6, I think I'm just setting up the column because I keep putting negative numbers.
Oh, that would be freaky. Let's see. So this problem involves triangle ABC. The measure of angle B, so let's just go right into it. The measure of angle B is twice the measure of angle A. So it goes right into an equation that kicks ass. Where'd it go? The measure of C is 80 more than A. And then it says find the angle measures. So what's my third equation? Beautiful, because I know all the angles in a triangle have to add to be 180. I love it. Now here's a really nifty, this is what I mean by you don't always have to follow the rigid steps we did. I don't know if anybody realizes this, but the reason this equation sucks is because it has A and B and C. But what's B? 2A.
I think 3A, not A, not 2A. Because it said 3 times.
No, this is number 6. Right, number 6?
Uh-huh.
Yeah. So it says twice, yeah. Cool. The measure, funny, okay. B is 2A. C is A plus 80. So this is one situation where I'd actually use substitution, not elimination. Because here I got A plus B. Well, what's B? 2a plus c. Well, what's c? So I just substitute those in, and I get one equation with one unknown that kicks ass. Will that always work? No. Right? But here, do you see how the first equation doesn't have a c, the second equation does not have a b? So there's probably a quicker way to do it because I've already lost some variables. So this is one situation where there is a nice, quick way to do it. That doesn't answer your question as to what went wrong the other way.
I know what I did wrong. It's
Oh.
that I only like I took 1 and I put it in 3, and then I didn't realize that I could put 2.
Oh, I got you.
And so then
Understood. Okay.
put that in there.
So your 4 equals 100, you keep going to there. Cool. Okay. Yeah.
Can you do 21 and 9.4?
No. Yes, I 21. So this is it just says this here. So solve this system. And it says it like that. These solve this. So, which variable would you eliminate? Yeah, the x is nice because it's just a 1. You're right. In fact, does it say a specific method? Oh, so this one says specifically substitution. So which variable would you solve for? I would definitely solve for the x because it has again, it's not going to introduce any fractions, right? So if I take the first equation and solve for x, I just have to add the 4y over. So now I know that x is that. And I just plug it in. So I get 5 times x, but x is 4y plus 3. Plus 3y. A really big mistake is people forget that because it feels like you've already written enough. But you got to write 5x plus 3. Don't leave the plus 3y out or else you get freaky answers. So here you get 20 and 3 is 23y plus 15. I think this is the one that comes out a little bit ugly. Yeah. You do get a couple of these have some kind of ugly answers, but not all of them. Yeah.
You know, can you, let's say the one is, all of it's a fraction, and the second one's a fraction. Can you use the...
Oh, yeah.
Can you kill the fractions?
Definitely.
To solve?
I would, very first thing, if I had like 1/2 x minus 5, 6y equals something.
Can you just solve, like, the kill the fractions?
Yeah, I would very first thing is multiply by the
So you
LCD.
don't have to do it with, okay, that's fine.
And then I would look at what I got and start doing the process. Like I don't even have a problem yet until I kill the fractions. You don't have to do that. You can actually work with the fractions directly. But again, that just brings in more places to make mistakes. Right? So if you have a system of equations, they both have fractions running all over them. Very first thing is just multiply both by the LCD of each. And then look at it fresh. Elimination, whatever. Yeah.
Would you mind finishing it? Because I got that far, but it was just the steps afterwards.
So now the horrible thing is when you get an answer like this, so you get the other thing, you've got to just plug it in. And one nice thing about substitution method, you're always going to have an equation that's solved already for the variable. So now I just have to do 4 times y plus 3, and now I just have to do that. So multiply, get LCD, put them together. Yeah.
11.2, 11.2, 9 and 12.
Oh, okay. I think 12, maybe something went wrong specifically with that. Well, that one should be too evil to set up. Number 9 might be kind of gross to set up. Yeah, number 9 is just, ugh. All right. So this one, I don't want to write all this down. This one says, a good healthy diet should include so much fiber each day. a breakfast of 2 bran muffins, 1 banana, and 1 cup serving of Wheaties contains 9 grams of fiber. Okay, so this is not that bad. So what I've got running through this whole thing is bran muffins. Right, bran muffins. Bananas and Wheaties. Right. Copyright. So I just have to assign these variable names. So banana should be B. Bran muffins can't be B also, so I'll make them M. And Wheaties I'll make W. Right. So now when I read this, a breakfast of 2 bran muffins and 1 banana and 1 serving of Wheaties contains 9 grams of fiber. See, I mean, now the sentences just go right into equations. The next one says, a breakfast of 1 bran muffin, 2 bananas, and 1 Wheaties contains... Okay, so 1 bran muffin, 2 bananas, and 1 Wheaties. Wheaties is a weird word. Contains 10.5 grams of fiber. I mean, that's a really nice translation from English to math. Just bam, bam, bam. 2 bran muffins, 1 Wheaties. 2 bran muffins and 1 Wheaties. Put away with it. Contains. Where'd he go? 6 grams of fiber. All right, it's the day you forgot to go get bananas. I guess. And now you just start attacking it. Notice how I've already got one equation that's missing B. So I'm automatically, that already set it up for me. I've got one equation that has just 2 variables. I'm going to kill B again between these 2, and then I've already got my 2 equations with just M and W. You see, anytime you're missing a variable already, it should truncate your work. It should shorten your work. So now I just have to, between these 2, I can kill the B, and with this one I can kill the M or the W. Is that cool? So I would take, what would I do to 1 to kill the, multiply by negative 2. Negative 2 times 1 is negative 4M. W negative T. 2 is M plus 2B plus W equals 10.5. Add these together, I get negative 3M minus W equals negative 7.5. So now between these 2, I can actually add them directly together the way they are, and it kills the W. Yeah. And then I'm almost there. Do you guys see that? Because again, your goal is to kill a variable twice. Well, one of them came pre-dead. Dead on arrival, right? So then I just got to kill it one more time. Very violent algebra I teach, I know. Mm-hmm. Yeah.
From 9.4, 45.
Oh yeah, all right. So this is one about private tap lessons and group classes. So it's $20 for a private lesson and $12 for a group lesson. That's probably going to call them P and G. One Wednesday she earned $216 from 14 students. You start to see the pattern here. You will almost always have an easy equation, which is the total equation, right? What's one equation going to be here? Yeah, the private students plus the group students makes 14. And then the other one's going to involve the money. How much money did she make from these people here? Yeah, 20 times P, $20 per, plus $12 per, gives her the total money she made. And now elimination, substitution, whatever you want to do. So it almost seems like they didn't give you enough information. It's like 2, 16, 14, so, what? So that's how quick it could be. This gives me one equation, this gives me the other equation.
And you just multiply it by 20?
Yeah, now you can multiply by 20. If you ever notice that you can reduce, like I could at least divide by 2 here, if not 4 would actually work too. I could divide by 4. That would make it a little bit easier, but not easier enough. I would just do like you said, multiply by negative 20 or negative 12. You know, just get killing. Is that cool? I mean, the setup is the hard problem. The solving this should be I don't care what it looks like, you should be able to solve it. Yeah.
So when looking at that, how do we know like the difference between that being that kind of problem versus like a word problem?
This is a word problem.
Well, I mean like the other kind of word problem.
Oh, where you have the trick here is that there's no direct relationship between these two. Like they didn't say this is twice this or right. So I can't. You know, if there was a direct relationship, then one of them could be x and the other one would be 2x or something. Then I would only need one variable. So that's what you're really asking is, how do I know I need 2 variables here, not just one? Right? It's because they didn't give me a direct relationship between these. They did, sort of, actually, but not like I'm used to. I know that together they make 14, and I know that the money from each makes this. That's 2 separate ideas, 2 equations. Bang. So it's whenever you can see 2 ideas, a number of people and a money, or a number of quarters and a number of dimes, or, you know, something. Yeah.
Hey, could you show me the setup for 48 on that one too? Same page.
Oh, 48 is a little weird.
Yeah.
Not just because the place is called the Nut House, but it's got 10 kilograms of mixed cashews and pecans worth $8.48 a kilogram. So cashews sell for $8 a kilogram, and pecans $9. So does it make sense that if you mix the two together, you should get a price in the middle? It's sort of like if I had pure pecans and then I pour some cashews in there, I'm diluting the price. Does it make sense? I'm putting some cheaper stuff in there, so the price at the end should be somewhere in the middle. In fact, can anybody tell me which one there's more of? What's that closer to, 8 or 9?
9.
8.40 is closer to 8. So there's more cashews in there, right? If they were equal amounts of each, then it should be 8.50, right in the middle. How much of that do you have to actually know to do this? None. But it's good to kind of go in knowing that this should be higher. So the number of cashews I'm going to call, incredibly enough, C and P for pecans. Yes, sir. Yeah.
Do we really need that 10 kilograms? Because we're only trying.
We do.
Oh, okay, that's what.
Because what's the first equation going to be? I know that however many kilograms of cashews I have and how many ever kilograms of pecans I have to make 10. So there's my total equation.
That's right.
So the cashews plus the pecans must be 10. How many ways can I pronounce that? Sorry. Pecans, tomatoes. What about the second equation? Yeah, the cashews are $8 per kilogram plus $9 per kilogram. Now here's the trick. The mixture is $8.40 per kilogram. How many kilograms? That's the step that people forget. So if it's money times kilograms, this side better be money times kilograms, right? So everybody always forgets that 4 times 10 there. And I don't blame you because it's not easy to see that's needed. But this would be a total cost for all the cashews. This would be a total cost for all the pecans. This better be a total cost for the whole mixture, which would be $8.40 per kilogram times 10 kilograms. That's the step that's easy to forget.
So what threw me off. I just had 10. I just couldn't figure out where to put it.
Oh yeah. So it goes here, but it also goes there. 10 kilograms times 840 per kilogram is a total cost for that.
But you can divide it 840 over 10 to make it 20.
No. So this is per kilogram. So to make it money, I've got to actually multiply it by. Multiply by 10, yeah.
So then you would just multiply the 10.40 by 10 and then just go from there.
And now you just elimination, substitution, whatever you like. Yeah. I think they gave here. Yeah. Number there's example 4, blending coffees. So like I said before, I understand if you don't want to read the book, like a real book, or it does help. At the very least, if you're stuck on something, take a look at the examples. They very often will have one almost just like the one you're doing, and then you got the setup. And they show you right here, you got to multiply the money times the weight in the little table they made. And the white book is page 593. Yep. Anybody here right now that wasn't here earlier when I was giving stuff back? Make corrections on that. Due tomorrow if you want to do it. All right. How we doing? Hey, there's everybody. Huh? Yes, ma'am. Where are we at? Practice test. Number who?
1F.
Oh, okay, good. So that's the one I made a mistake on.
You did.
Totally. Yeah, I am not a teacher that says I never. Have you ever had a teacher that's like, I never make mistakes? That's too much stress. Screw that. I know I'm going to make a mistake somewhere. So 1F. And I totally own up to it. The reason I made the mistake is because I was trying to do it all in my head so I can try to save space on my sheet. So these, what's going to flip? What's going to move? Yeah, these are going to move down. And this one's going to move up.
Okay, so just the exponents of the variables?
Just the negative powered things are going to flip because that's what a negative power means. Everybody else is cool with where they are. These are the ones that don't like it. So those 4 are going to come down. So how many M's are going to have down here now? 7. I had 3 there, 4 more coming.
So you add it?
Totally. Because the step I'm skipping there is I have M3 here already. Those 4 M's come down. Why is the power positive? Because the negative did its job. It's gone. It's sort of like, what's 12 divided by 3? 4. It's not 4 over 3. That over 3 wouldn't be there anymore because it did its job already, right? So this is not going to be a negative power still because the negative's already done its job. It's gone. You applied the negative power. It's gone. That Z comes up, so you had Z3. You got another Z sitting there. This reduces to
By 3.
Yeah, by 3, so it's 4
4
elements. And then here's the mistake I made. I put my P4 down here, but there's 5 up here, 1 cancels, so it should be 4 left up there. Cool. And now you can just put those together and put those together.
Why is it? Oh, this is a P there?
Yeah, so you had 5 P's. If I divide one of them out, I'll have 4 left. Yeah, 5 minus 1. There's an understood 1 here that people forget about sometimes, right? Yeah.
On the practice test, can you do 2C?
I don't know if I can trust myself. Hopefully I did everything right after that. What's the way to handle this that so you don't have to worry about the fractions? Yeah, the LCD is 30. So if you multiply everything by 30, you get 3 goes into 30 10 times. So 10 times 1 is 10. 15 goes into 30 twice. 2 times x, 2x. 10 goes into 30. 3 times 7. And now that, easy. Alright. Subtract the 10 divided by negative 2. Yeah.
This is about about the homework.
Yeah.
So, was there anything else to do tomorrow with just the elementary algebra review or the moron systems?
So what's due tomorrow is the elementary algebra review and the moron systems.
Okay.
Cool. The inequalities stuff we'll do after the test. Not tomorrow, but
And you feel like
Thursday.
entering stuff in throughout this period, all that stuff's already like recorded?
yeah. I should have given it back to you, right? Okay. Yeah, so subtract 10, divide by negative 2.